Today I'm going to talking about non-cooperative matrix games with interval payoffs. This is joint work with Aykut Or, who is working mathematics department in the same institution, Çanakkale Onsekiz Mart University. Yeah, and this is my agenda. Firstly, I'm going to start providing some background on the theory of matrix game with interval payoff. Then basically, I would like to give briefly some information, some introduction about interval analysis, then matrix games with interval payoffs, and then I'm going to focus on the solution methods because, as you know, in a matrix games, the concept of game value and solution methods are very important. Yeah, and finally, I will give some reference while working, presenting this work. Yeah, let's start. Okay. Games are roughly classified into two major categories, cooperative games and non-cooperative games. And in non-cooperative games, an important from a conceptual and application point of view class of our matrix game. So, a simplest game is finite two-person zero-sum games. Summarizing a two-person zero-sum game in matrix form means that there is a matrix with G, AIG, of real numbers, so that if player 1 and 2 respectively can choose the play row 1 and clone 2, then the payoff to player 1 is A1, 1 and 2. And then the conventional game theory is concerned with how rational individuals make decisions when they are faced with payoffs. However, in the real world, sometimes the payoffs are not known and have to be estimated. So outcomes of a matrix game may not be a fixed number. Therefore, interval number whose integers are closed intervals suggested by many researchers to model under uncertainty. So, matrix game with interval payoff is the generalized form of a classical matrix games. And the two-person matrix game with interval payoff is defined by m time n with G, whose integers are interval numbers, as you see on the screen. Yeah, suppose that player 1 and 2 have respectively M and N pure strategies. If they choose their pure strategies, number I and number G, then the payoff to player 1 is stated by with an interval AIG left and AIG right. Yeah. And let's move to the interval analysis. But firstly, I will like to show the definition of interval number. Yeah. An interval number is a subset of a real line of the form with this. And in here, a left is referred to the lower bound of an interval number, and a right refer to the upper bound of an interval number. if these numbers are equal, then A is a real number. Yeah. And MA is called midpoint, and RA is called radius of an interval number, as follows. Then, yeah, I will show some operation over interval numbers. Yeah, the elementary arithmetic operation, yeah, this is binary operation between two interval numbers A and B. Firstly, A plus B is denoted by this interval number. A minus B is denoted by this interval number. A multiply B is denoted by this interval. And for division operator, A division B is denoted by this interval number. And last one is scalar product, as you know, is defined by partial function with it. Yeah. Okay, in interval analysis, one of the most important concepts is ordering the interval numbers. So firstly, I would like to say that there are three kinds of interval numbers, which are disjoint intervals, overlapping intervals, and nested intervals. Firstly, to compare strategy and payoffs for a matrix game with interval payoff, we also need a notion interval for ordering interval numbers. Yeah, Moore most comprehensive work dealing with ordering interval numbers in 1979, and firstly defined a transitive order relation over intervals. This relation is an extension of less than sign on the rail line, as with this. In this example, firstly, I give an disjoint interval because A right is less than B left. So these intervals are called disjoint intervals. It's a simple one, simplest one. Yeah. So we can say A is less than B by Moore. Okay, but another relation is extension of the concept of set inclusion. In this example, yeah, these intervals are called nested intervals. Yeah, so by using this relation, we can say A is the subset of B. But the extension of the set inclusion here only describe the condition that interval A is nested in B, but it cannot order A and B in terms of value. So let's move to another relation. Ishibushi and Tanaka in 1990 approach a new relation. So they approached this situation more prominently. In their approach, the relation orders overlapping intervals. Yeah, under these inequalities. Yeah, in this example, A and B, two interval numbers, and these interval numbers are called overlapping intervals. Yeah. So then A is less than B. Yeah, and more generalization, the relation for ordering interval numbers is this definition. Yeah. In 2000, Sengupta and Paul introduced a new definition about ordering interval numbers. Yeah. Let's say A and B in two interval numbers on the rail line. Yeah. MA is less than MB. Yeah. In these examples, A and B, these intervals are overlapping intervals. Okay, let's try to these, let's use this relation. MA is equal 9 divided 2, because midpoints, you know, and MB is equal to 5. So MB is less than MA is less than MB, hence A is less than B. Yeah. Till now, the basic concept and definitions of the interval analysis and the relations for ordering interval numbers are given. And then let's move the, yeah, let's check the all kind of interval numbers are ordering by the next, yeah, this relation. Okay, let's check. A and B, two intervals. Firstly, MA is equal to 1 divided 2. MB is equal to 9 divided 2. Okay, these intervals are overlapping intervals. So we can say A is less than B by using the relation studied by Sengupta and Paul. And another type of interval number, disjoint. We can also use the relation for disjoint interval numbers. Yeah. In this example, MA is equal 11 divided 2 and MB is equal to 27 divided 2. So A is less than B. Yeah. Now we checked all kind of interval numbers by using the relation studied by Sengupta and Paul. Okay. Now let us consider the matrix game with interval payoff. Yeah. Player 1 choose the first strategy and player 2 choose the second strategy. Then the payoff to player 1 is this interval. Yeah. And in a matrix game with interval payoffs, the existence of the equilibrium point of the game is evaluated according to strategy type. So the game cannot always reach equilibrium in pure strategy, but in mixed strategy, the game always reaches to an equilibrium. Yeah, so let's move the in pure strategy saddle point. Yeah, and if there is an equilibrium point of the game in pure strategy, then this is the value that lower value of the game is equal to upper value. Yeah, so this interval is called saddle point in pure strategies. Yeah, but these values don't have to be equal. So when they are equal, this interval number is called saddle point. Yeah. Here is an example. Let's consider the 2x2 matrix game with interval payoffs as follows. Yeah, we can compute a lower value max min and upper value min max. Yeah, in this example, lower value is equal this interval. In this example, you can use the relation for ordering these interval numbers. Any questions?
Yes,
Yeah,
I have a
George,
question.
please.
In this representation, player 1 has two strategies, I1, I2, or 1-1, 1-2, and the other one 2-1, 2-2.
Yeah,
the
true.
numbers that are written in the cells. So if player 1 is playing I1 and player 2 is playing I1, so
yeah,
player 1 is getting what?
Getting what? This interval, -1 and 1.
And player 2?
This interval. And first player choose the first strategy and second player choose the second strategy. Then the payoff to player 1 is this interval, 1, 3, closed interval.
And to player 2, what is the interval?
Yeah, this is zero-sum games. So the second,
okay.
yeah,
okay,
the
okay,
second,
okay.
Yeah, second player.
No, sorry, you didn't mention that it is a zero-sum game in all the definitions you mentioned. Okay, now I got it.
Okay.
Thank you.
You're welcome. Thank you. Let's continue the example. The upper value we can compute min max. Yeah, this is this interval. Hence, max min is not equal to min max. So it means that the matrix game G with interval payoff has no saddle point in pure strategy. Yeah, so we should move to the mixed strategy, as you know. Okay, Michelle, please.
My question is, when you're computing the min and the max, you're using your definition of using the midpoint to compute which is the highest one?
Yeah, we use midpoint, which is the highest one. This interval is highest one.
Maybe this is a stupid question, but if you're using the midpoint to decide which is the best one, why aren't you just using the midpoint and transforming it into a regular game? It means that you can replace these intervals by their midpoint, which is a single number. Or am I missing something?
No. If you want, I can show how I found the max and min interval on the row and column. Because by using midpoint is enough to order these interval numbers. And so in pure strategy, we only compute the upper value and lower value. Yeah.
Okay. Maybe I keep my question for the end. Okay.
Okay.
Sorry.
No, it's okay. Yeah, let's move to the mixed strategy. In a matrix game with interval payoff, mixed strategies are not different from the classical matrix games. Even mixed strategies are the probabilities of playing their pure strategy, as you know, X and Y. And then the expected payoff to player 1 can be computed as hxy, and this is an interval number and is equal to x times g times y transpose. This is a matrix representation we can use. And yeah, you know, in pure strategies, there may not always be an equilibrium point. In this case, we should move to the mixed strategy. And for player one, the gain floor can be represented by V star. And conversely, for player two, the loss ceiling can be represented by W star. Yeah. And yeah, as you know, from the classical matrix games introduced by von Neumann theorem in 1928, yeah, so this inequality is valid in matrix game with interval payoffs. Yeah. Okay. Now let's move to the solution methods in matrix game with interval payoff. The concept of solution in classical matrix games is characterized by the size of matrix. Yeah. So the generalization of these methods in classical matrix games exist in the literature of matrix games with interval payoff. For instance, the most effective and main solution methods are here, 2 times 2 games and graphical solution for 2 times m or n times 2 games, and m times n games we can use linear programming method. In matrix games with interval payoff, of course, algebraic methods, 2 times 2 games with interval payoff, and also graphical methods for 2 times m games. And interval programming models by introduced Lee. I will show and I will explain the next slide. Yeah, we can compare these solution methods in between classical matrix game and matrix games with interval payoffs. Yeah. And in here, Nayak and Paul in 2006, in this paper, studied solution of rectangular interval games using graphical methods. They used graphical methods for solving matrix games with interval payoff, and then they conducted conducted in 2009 another article. They used linear programming for solving matrix games with interval payoffs. In this article, the concept of solution in both of articles is given by these inequalities, as you see, these and these. And with this system, X star and Y star and V, this is game value, and these are the optimal strategy of the players, respectively. Yeah, and then in 1911, Lee found that there were a lot of virtual mistakes on the on this article. Yeah, this article. And he points out and corrects these mistakes in the previous one entitled Notes. Yeah, this article on notes. So he stated that there does not always exist this system, X star, Y star, and V. Yeah, such that it satisfies these inequalities. Does Lee introduce the concept of solutions of a matrix game with interval payoff in 2011? He put forward linear programming approach, yeah, to solve matrix games with interval payoff, or we can say interval valued matrix games. And then Lee et al. In 12 published another article, interval programming models for such games. Yeah. In this approach, there is a system, yeah, this system, X star and Y star, and V and W. Yeah, this is game value for player 1, and this is game value for player 2. Yeah, such that this system satisfies these inequalities. Okay, let's move the next definition for us, and yeah, sorry, yeah, this definition is really different as studied by Lee. Let's have a deeper look at what he found out. Yeah, the reasonable solution, let's say V and W are two interval numbers. If there are X star and Y star satisfying these inequalities, then the system is called reasonable solution of the matrix game G with interval payoffs. And by the way, V and W are called reasonable value for player 1 and 2 respectively. In this case, X star and Y star are called reasonable strategy for player 1 and 2. However, the reasonable solution is not the solution of the game, of the matrix game with interval payoff. Yeah, so I will the definition, the following definition. Yeah, let's move to the definition. Okay, V star and W star, yeah, let be two reasonable values. If there are no reasonable values, V prime and W prime satisfying these inequalities, then the system is called a solution of the matrix game G with interval payoff. And also X star and Y star are called an optimal strategies for player 1 and 2 respectively. We can say V star and W star are called player 1's gain floor and player 2's loss ceiling respectively. Yeah. We focused on some solution concept of matrix game with interval payoffs, and also we are working already working with these some kind of work, and then while presenting this work, I got the help from some important reference. I want to show you, and all of reference is in here. Yeah,